Today's problem is one of the most famous and hard problem in string algorithms, minimum window substring. You are given two strings, a large string S, a target string T, and your goal is to find smallest substring in S that contains every character of T. Now, at first it might found straightforward and you can think like, let me check all the substrings, but that quickly became very inefficient. So the real challenge of this problem to not just solving it, to solve it efficiently. And key to solve that kind of problem is the most powerful algorithm in interviews, the sliding window technique. In this video, we will first understand the brute force idea so the logic becomes clear, and then we will start building the optimal sliding window solution step by step and then implement it in Java code. This is very important problem when you are preparing for coding interview because it teaches you how to manage dynamic window, character frequency and two-pointer technique all together. So let's jump in and break down the minimum window substring. This is a hard category of question, but let's try to tackle this in a simple way. Once you get the idea what is asked in the question, it is simple to solve it. If you see the input given to us, it is a sequence of uppercase characters, or we can say a string, and we have given another string and we have to find a substring in which this exactly contain in that substring. For this example, B, A and C contain ABC. Maybe it's in different order, but we have to find it. And also if there is double A, B, C there, so we have to find a substring where the double A should appear. Now let's try to do it in a brute force manner. So if you try to see this image, we are trying to get every possible combination of string, and at the end we'll find out if the substring contains that string or not. This will give you big of n square time complexity. Let's see this in action for more detail because you might feel difficulty to reading this image. We just declare a min length with maximum value, so everything what we got in the future is minimum. We declare the empty string as a result to return at the end. Now let's take a for loop to iterate over the given string S character by character. Now take another for loop within that, so it will help you to figure out all the other possibilities of substring within that string. The substring of this one is decided from the beginning of I to the j. So for every iteration, this sub is considered as the current substring, and we try to find if this substring containing our required character from T or not. For that, we will going to introduce another method called contains all. We will pass our sub and the given substring T. So this will check the given or the current substring is containing the characters in that T or not, and also it will check if this new length is the required minimum length or not. For both of the cases, first try to see this contains all method. So this contain all method is simple. We are just trying to match each character within our substring that we found. So that will return true or false at the end. Also, we will introduce min length and result as substring, the current substring. In this way, the substring length update the min length and the result updates in result and will return the result at the end. Let's try to check if this works or not. So yeah, this is working, and let's move on to a brute force approach that we have discussed. Now let's see this sliding window method after the brute force. So here we are also using a dynamic length window. Start from the beginning and it will expand or shrink as per the condition, and at the end we'll get the final substring. Now let's see that in action for more detail. So on the same input, let's try to implement the optimal approach. So first we are checking the edge case, because for any given input, if T is already greater than S, then there is no way to find the minimum length of a string contains. So this will return empty string. Then we'll declare some map for calculating the needed string and the current window string. So this will keep on storing what we need and what we currently have. Now first we fill the need map with all the characters which are in T, so that we actually get the frequency of characters which is our goal. Now we declare some variables which we are going to use in our program. You will get to know each variable and their work going forward. But think of like that, these variables are not predefined. You can't think of these variables at the beginning. You might think of some of them, but going forward you can declare these variables. As I am going systematically, that's why I have declared this variable initially. So don't think like that you have to mug up this and declare this variable initially. Just try to implement the logic of dynamic window, and whenever you need some variable, just declare it. Now let's implement the logic to find the minimum window. For this one, as we have already introduced our left variable, we are going to introduce right variable, and as this is dynamic window, we are going to expand the window based on condition, and we are going to shrink the window based on some condition. So as you know, we expand toward right and we'll shrink from the left using right and left pointer. So as we have introduced this for loop, so right pointer will always expand. So whatever we put our logic, we have to be aligned with this. Now for this for loop, we'll check what is the new character that we have and we'll store in C. And for populating our window, we'll keep on checking if that C character that we found newly is already there or not, and we will try to increase the count of that. And if the needed map contains the character, also the frequency of that character matches with the current window of character count, we can increase our count of have as +1. And we have already declared the need count at the beginning, which is the size of the needed map. We will try to check this every time with have, and we will update the answer if the current length is less than the minimum size. If that is the case, then we will update the minimum size and we will update the start. And also, if condition fails or any other case, we try to shrink the window from left. We'll just take the left character and we'll just decrement the count of that character from window. And if it is the case that needed map contains left character and the window's length of that character is less than the needed one, then we can say have minus minus. And we'll also do left plus plus every time. And at the end, we'll check the substring, which will be the start and start plus min plus size. So either we return the min size that we have calculated, or we will return the substring. Sorry, we will just check min size. If it is equal to max value, then that will be an edge case. We will return just empty string. Otherwise, we will return this substring. So let's try this one. Yeah, it is returning what we are expecting. So let's try to run this in Leetcode. So I have pasted in Leetcode, running simple test cases. It is all passing. Let's try to submit. It is actually beating 23% of the programmers, but we are working on sliding window. And that's how we solve minimum window substring using sliding window technique. We first looked at the brute force approach, which checks all the substring and ends up giving you n cube time complexity. Then we optimize the solution further by using sliding window pattern, 2 pointers and frequency map, allowing us to expand and shrink the window dynamically. This reduces the time complexity to big O of n, which is exactly the type of solution that interviewer expect for this pattern, the problem. So I will see you in the next problem.